So now we talk about protocols and standards, and just like human communication, networks can communicate, have to establish these rules before the communication. So the best way to visualize these rules is to put them into layers, and then we will talk about what are the benefits of dividing these rules into layers. Here we define a protocol. A protocol is a subset of these rules that govern the communication in that layer. So a protocol is a very important aspect which defines this subset of rules that govern the communication in a certain layer. So so this for a human communication, as we said, these communication rules can be formal, in which case we have to define certain language and certain grammar and so on and so forth, and can be like implicit, which means that it's agreed upon that we need to talk in a certain way. So to dig deeper into how the protocol works, a protocol defines a set of rules and characteristics that have to be established for a successful communication. So for example, how the message is formatted or structured. As we can see here in that figure, the message is composed or structured as an IP and data. So how this message can be formatted. And as we said before, this is like the envelope or the header, and this is like the content of the message. Also, the process by which the communication can be established. So for example, um, there is a protocol that allows all the communicating entities to agree on a certain characteristic. For example, if one of the pathways, if one of these paths is actually down, we will have to notify each other in a certain way. It's down. Also, we have to agree on when an error can be rectified. Like, for example, if a message is sent and the message has arrived here in error due to a certain problem in the network, then whether or not we have to exchange this message again to maintain reliable communication. Also, the setup and tear down between two entities to communicate is also part of a certain protocol. So in general, a protocol defines a subset of rules that have to be agreed upon in order for us to communicate. And as we said, the best way to visualize these protocols is to stack them into layers. So for the communication to happen successfully, multiple of these protocols, each one defines a subset of rules. They have to interact together in order to facilitate the communication. So for example, we have Ethernet, which deals with a specific medium, whether this medium is wireless or wired and so on. Then IP, which is concerned with moving data or moving packets from one source network to another remote network. Then we have Transmission Control Protocol or TCP, which is concerned with moving segments and transmitting segments of data between two different applications. Then we have the Hypertext Transfer Protocol, which defines the interaction between a web server and a web client. So the interaction between all these protocols stacked together will define all the rules that are required to guarantee successful communication. Then we define what we call a protocol suite. A protocol suite is a set of interrelated protocols that have to interact together in order to guarantee the successful communication. So, for example, TCP/IP is a protocol suite which defines the interaction between these protocols together in order to facilitate the communication. So, for example, if I combine HTTP with a protocol from here, they will not interact successfully in order to deliver or in order to facilitate successful communication. So a protocol suite is a group of interrelated protocols that have to work hand in hand in order to uh, 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 facilitate successful communications. Um, these protocol suites, they are defined through different organizations or companies that interact together in order to define these protocols. Some protocols are standards, in which case the whichever company or whichever person developed these set of specifications that describe the rules for specific protocols, like for example HTTP. These specifications have been agreed upon worldwide and endorsed by the network industry, that this is a standard, in which case it's an international standards that anybody in the world can actually develop it or use it. There are certain protocols that are proprietary. For example, we will talk about EIGRP or enhanced EIGRP as a routing protocol, and that's a proprietary protocol developed by Cisco. A proprietary protocol talks about a protocol which is not endorsed by the international community. However, it can be used within one or group of companies as a de facto standard, or it's not an international standardized protocol that's agreed upon and endorsed by an international body. Okay, so that's the difference between a standard and a proprietary protocol. A standard is an agreed upon protocol specification that's endorsed by the international community, whereas the proprietary protocol is um, a set of specification for a protocol which is used within a company or within a group of companies. Okay. So this is a historical timeline of how the internet was developed. So we will see that at the beginning, the in late 60s, the first project that started in UCLA, in University of California at Los Angeles, which is supported by DARPA, or the American Defense Department, was to establish communication between four mainframe computers. This has evolved to late 70s and late 80s, where there are certain extensions, and then there are some international organizations have been established to coordinate the development of certain protocols which are internationally agreed upon so that they facilitate the communication. Some of these groups are IETF and IEEE and ITU and so on. And these organizations have been established to coordinate the specification of these protocols to facilitate the communication. So we can go through this timeline to understand how the evolvement of these protocols and standards have come about. So as we said, the protocol suites are stacked into layers, and they define the set of protocols that interact together in order to facilitate the communication. So for example, one of the very common and the most common protocol suite is what we call TCP/IP protocol suite. So this TCP/IP protocol suite defines all these set of protocols that most of them are standards. And these protocols, they interact together in order to maintain and facilitate successful communication. So we have domain name service, we have DHCP, and we have SMTP, we have POP, and of course, for a certain application to work, it needs to use some of these protocols in a specific combination in order to make sure that the communication will happen successfully. Each of these set of protocols defines a set of rules and format of the message and message timing and message delivery option and so on and so forth in order to facilitate the communication. So this is an activity that tests your understanding for how these protocols are actually organized, which we will go through in class, and therefore we will skip it. So as we said, the protocols, the process of developing standards through set of protocols is coordinated and organized through what we call standards bodies or standards organizations. These organizations are international bodies that um, you know, they define certain technical groups which can work together in order to develop the specifications for some of these protocols. Some of these organizations are IETF, IEEE, ITU, and so on and so forth. So these standard bodies are actually organized or divided into a hierarchy, a specific hierarchy, which defines how these international bodies can interact together to produce the protocols. So, for example, we have what we call the Internet Society Corporation or the Internet Society Organization, which is the highest body that's concerned with developing all the protocols over the internet. This ISOC, they oversight or they coordinate or they control the development of these standards through what we call the Internet Architecture Board. This Internet Architecture Board defines the requirements for some of these protocols for some organizations to go through. So, for example, Internet Engineering Task Force is one of the standard organizations which defines certain working group. Each of these groups usually work on a specific protocol. For example, IP or the Internet protocol is developed by one of these groups. And the Internet Research Task Force defines also the requirements for certain protocols on a long run, like for example IP version 6 or some of the features that have to exist in the internet in order to sustain the successful communication over the internet. So in other words, the IETF talks about short-term development of protocols, whereas IRTF talks about long-term development of these protocols. Okay. And so some of these standard organizations, they also develop, they are concerned with the development of certain protocols, like for example IEEE or the Institute of Electrical and Electronics Engineers. They define the protocols in the lower layers. So as we will see later that these protocols, they govern the communication in the lower layers in the network access layer. Whereas some of these organizations, they are concerned with developing protocols in the higher layers. For example, IETF mainly develops the protocols in the higher layers like TCP, like IP, UDP, and so on. And again, we will go through these protocols in details later on. One of the very famous standard organizations is ISO. As we all know, ISO is a standard body which standardizes different protocols in different domains actually. So the International Organization for Standardization, or ISO, it's the largest standard body in the world, and they develop actually protocols and products in different domains. One of the very important products or definitions that ISO produced is what we call OSI. So ISO produced what we call Open Systems Interconnection, which is a reference model. A reference model, as we will see later, is a set of requirements that governs the communication in a certain layer. So the reference model is a definition or a specification of rules in a certain layer, and it's decoupled, or it's not dependent on a specific protocol suite. So in which case we have reference model and we have protocol suite, and we need to know the difference between the two. So we'll talk about the difference between what protocol suite is and what reference model is. So now we talk about reference models. So be aware of the fact that we have three definitions of very important concepts here. We have what we call protocol suite, which is what we define as a group of interrelated protocols that have to work hand in hand in order to facilitate the communication. We talked about a reference model, which one important example is the OSI reference model, which is defined by ISO, and that defines the set of requirements in each layer in order to facilitate the communication. Well, the reference model defines an abstract definition of the function in each layer, but it does not provide the detailed information on a specific protocol in a specific layer so that you maintain the communication. Again, a reference model defines a set of requirements in each layer in an abstract way, but it does not provide the detailed information or the detailed specification of a specific protocol in this layer. Unlike what we call a protocol model, one very common example of a protocol model is what we call the TCP/IP model. A TCP/IP model defines the function that matches a specific protocol suite, in which case the TCP/IP model defines the detailed specification of all the protocols, not all, but of the protocols, how they work in a specific layer. So the TCP/IP model provides all the detailed specifications of the protocols in each layer. So again, we have the protocol model, which defines the detailed specification of certain protocols in each layer. We have the reference model, which defines an abstract specification of some requirements or the main requirements of how protocols in each layer works. And we have a protocol suite. Protocol suite is the set of interrelated protocols that have to work hand in hand in order to facilitate the communication. So the OSI model defines 7 different layers, and it defines in abstract way the function of each layer. For example, physical layer deals with the mechanical and electrical function of how the bits or how the different signals can travel through a specific medium. The Datalink Layer defines or describes how the link can be established to exchange information between one entity and another. Network layer defines or provides the services to exchange individual pieces of data from one source network to a remote network. The transport layer defines the services to segment and transfer the information between two end devices or in between two end applications. The session layer governs or manages a specific session between the two entities that organizes how data can flow into that session. The presentation layer provides a common representation for the information, in which case we have to encode the message in a certain way that can be transmitted over the network. And then the application is the entity that composes the information or initiates the end-to-end connectivity through um, uh, composing the information and sending the information through the presentation layer in a specific format. Okay. Um, so the TCP/IP protocol model um, defines the interaction of four major layers. Unlike the OSI model, which defines or divides the network functionality into 7 layers, TCP/IP model defines the detailed specification that divides the network functionality into 4 major layers. The first layer is the network access layer, which controls the hardware and deals with how the medium can be used to send and receive data and signals across the different types of media. Where the internet layer determines the best path between one source network and one remote network to maintain end-to-end communication. Transport layer supports the communication between end devices, and then the application which represents data in a certain way for communication. Um, so in order to understand the different layers between TCP/IP model and the reference model, there is a mapping between the TCP/IP model and the OSI model. So um, the application layer defined by the TCP/IP protocol model roughly matches the definition of 3 layers in the OSI model, which are session, presentation, and application. The transport layer is the same, matches as one-to-one. The internet layer matches the network layer defined by the OSI model, and then the network access defines the functionality of both the physical layer and the data link layer.